Now let us examine the various resonating structures of benzoic acid. The COOH group contains electronegative atom, that is oxygen. Two electronegative atoms are there, and again sp2 carbon is electronegative, and benzene ring contains 6 sp2 carbons. Now regarding the inductive effects, the COH group wins over benzene ring because it contains two most electronegative atoms, that is oxygen. So you can say the COH group exerts minus A effect, and again the COH group exerts minus M effect, where the pi bond here polarizes and shifts in between carbon and this carbon, and this pi bond shifts over oxygen atom, giving it a negative charge and a pi bond here and a positive charge at the ortho position. Now this pi bond shifts its position to a position in between these two carbons, and we get a positive charge here, and this pi bond shifts here and we get a positive charge here, and those structures are shown here. And finally this pi bond shifts in this direction, and the lone pair over oxygen atom shifts in between carbon and oxygen, creating the pi bond. So we find that in the ortho and para positions there are positive charges, so they are less electron rich, and the meta position is having no charge. So compared to ortho and para positions, the meta positions are electron rich, and again we say the benzene ring is deactivated, in the sense electron density is withdrawn from the benzene ring by inductive mechanism as well as mesomeric mechanism. So whenever an electrophile approaches the benzene ring, it approaches at the meta position where there is no positive charge. So nitration of benzoic acid gives meta-nitrobenzoic acid, and we say the COH group is meta-directing. And again, since the ring is deactivated, nitration will be difficult. So extreme conditions are required for nitration of benzoic acid. Now some conversions from benzene, that is first preparation of methyl benzoate C6H5 COOCH3. Now first we have to introduce a methyl group in the benzene ring, and for that we use CH3Cl and AlCl3, and one position the H atom of benzene ring is replaced by CH3 group and HCl is removed, and then this CH3 group can be oxidized using alkaline KMnO4, and we get COOK or Na depending on the alkali used, and then on acidification we get the COOH group, so H positive indicates acidification. Then an acid and alcohol can react together, eliminating a molecule of water. The OH group of COOH combines with the H of alcohol, removing water, and then OCH3 group is attached. So this is methyl benzoate, and this reaction is catalyzed by concentrated sulfuric acid. So that is the method of conversion of benzene into methyl benzoate. Now how will you convert benzene into para-nitrobenzoic acid? Now we should have an ortho-para directing group on the benzene ring first, and for that we use CH3Cl and anhydrous AlCl3 to introduce a methyl group in benzene ring, so that we get C6H5CH3, that is toluene. Then we can nitrate this toluene, so that methyl group, due to its plus effect, and more than that, the hyperconjugation of methyl group creates electrodensity at the ortho and para positions. so that the para-nitrotoluene is formed predominantly because the auto position there is steric effect of the methyl group. So the major product will be para-nitrotoluene, and we can separate ortho and para-nitrotoluenes from each other by a method called fractional crystallization, and you can isolate para-nitrotoluene, and then it is subjected to oxidation using alkaline KMnO4 followed by acidification, so that CH3 is converted to COOH and we get para-nitrobenzoic acid. Now para-nitrobenzaldehyde, a similar method is used. First of all, we methylate the benzene ring using CH3Cl and anhydrous AlCl3. We get toluene, that is methyl group introduced into the benzene ring. Then nitrate this toluene to get para-nitrotoluene, and you will get orthonitrotoluene as a minor product separated by fractional crystallization methods. And then oxidize the CH3 group using chromyl chloride CrO2Cl2. You get the aldehyde group and we get para-nitrobenzaldehyde. Now for the preparation of meta-nitrobenzoic acid, you can nitrate the benzene ring using mixture of concentrated HNO3 and concentrated H2SO4. We get nitrobenzene. Then alkylate the nitrobenzene. Nitro group is meta-directing, so methyl group enters into the meta position. Then on alkaline KMnO4 oxidation, the CH3 group is converted to the sodium salt of the carboxylic acid. On acidification, H positive, we get COOH. Now we can first start with the benzoic acid and then nitrate it. For that, you have to again pass through the methyl derivative of benzene, that is a reaction with the CH3Cl and AlCl3. We get methyl benzene, that is toluene. Then oxidation, we get alkaline KMnO4 oxidation followed by acidification, get COOH, and then you nitrate the benzoic acid to get meta-nitrobenzoic acid, that is the acid group is meta-directing, and that is another method. Then you to prepare phenyl acetic acid from benzene. Now for this, benzene is first alkylated using CH3Cl and AlCl3, we get toluene. Then chlorine in presence of ultraviolet light, free radical chlorination, the alkyl group is getting chlorinated to CH2Cl. Then using potassium cyanide, we can replace Cl by Cn. Then on hydrolysis, Cn group is getting hydrolyzed and we get phenyl acetic acid. So that is the conversion of benzene into phenyl acetic acid. So for question 4, another method of preparation, you take benzene and reaction with the CH3Cl anhydrous AlCl3, you get CH3 here, then alkaline KMnO4, followed by acidification, H positive, we get benzoic acid. COOH, then nitrated concentrated HNO3 and concentrated H2SO4. You get metanitrobenzoic acid. So this is another method to question number 4. Now, how will you bring out the following conversions in not more than 2 steps? Benzaldehyde to alpha hydroxyphenyl acetic acid. So, alpha hydroxyphenyl acetic acid, it is the derivative of acetic acid, and there is one alpha OH and there is CHOH group, benzene ring, and COOH group. Then this is alpha carbon, that is hydroxy group, and benzaldehyde contain only one carbon as the side chain, this one, and here we have to introduce one more carbon as COOH, and we know that a cyanide group on hydrolysis can provide COOH, so we try the addition of hydrogen cyanide in alkaline medium. We get CHOHCN, so this bond ionizes and HCN ionizes. H goes to oxygen, CN goes to carbon, and we get CHOHCN, and this on acid hydrolysis, CN group is hydrolyzed to COOH. So that is the method. Now, benzoic acid to metanitrobenzyl alcohol. Now here the acid group is metadirecting, so we can directly nitrate benzoic acid to metanitrobenzoic acid. Then an acid group can be reduced to CH2OH by lithium aluminum hydride, but the failure here is that the nitro group will be getting reduced to amino group. So we have to choose a specific reagent which will not reduce nitro group but will reduce COH to CH2OH, and for this the reagent used is B2H6, that is diborane. And THF is a solvent, tetrahydrofuran, and tetrahydrofuran is having the structure of this one. So it is a solvent, tetrahydrofuran. It is slightly polar due to the presence of oxygen. It is something like an ether and a less polar solvent. And in this medium, diborane reduces only the COH to CH2OH group, so we can keep the nitro group intact. So that is one method. Then benzoic acid to benzaldehyde, the reaction is simple. You replace the OH group by Cl using PCl5, so that COOH is converted to COCl. Then the reduction reaction, that is named reaction, Rosenmund reduction, hydrogen, palladium and barium sulfate. The CCl group breaks and 1H and 1H adds here. We get CHO plus HCl as the next product, or minus HCl is written here. So that is the method. Now, benzene to metanitroacetophenone. Acetophenone is first prepared, using CH3COCl and anhydrous aluminum chloride, so that COCH3 group is connected to benzene ring, and here one H atom of benzene ring is removed as HCl minus HCl, we can say, and the CH3CO group is getting connected. And then we use a mixture of concentrated nitric acid and concentrated sulfuric acid. This COCH3 group is meta-directing, so we get meta-nitroacetophenone. Then bromobenzene to 1-phenyl ethanol. See, the product here is 1 here and 2 here. 1-phenyl ethanol, it's a product, it's a secondary alcohol, and secondary alcohol may be prepared from a Grignard reagent and an aldehyde. So first of all, convert this bromobenzene to a Grignard reagent using magnesium and ether. We get phenyl magnesium bromide, a Grignard reagent, and then that is reacted with the acetaldehyde, so that MgBr portion goes to O. We get OMgBr, and then CH3CH portion connects to the benzene ring. Then on hydrolysis we get OH here, so that the product is 1, 2, 1-phenyl, 1-ethanol. Now complete the synthesis, each synthesis by giving missing starting material, reagent or products. Now this compound contains 2 acid groups connected to benzene ring, and this compound is called a PHTHALIC acid. Now SOCl2 is a reagent which converts COOH to COCl, so we get, if you are using excess SOCl2, we get COCl and COCl here, so that is the expected product. Now how will you convert benzene to this compound is benzophenone. Now a Friedel-Crafts type reaction is used. HCl is removed like this. We use benzoyl chloride. This compound is called benzoyl chloride, and then anhydrous AlCl3, you get benzophenone. So benzoyl, BenZoyl, benzoyl chloride, CHLORIDE. Now this compound is given, it's a ketoester and sodium borohydride, mild reducing agent, which will reduce CO group to CHOH, and it will not affect the COOH group. So we get this product, which on hydrolysis the compound breaks here and the HOH addition occurs, so that we get CH3CHOH, CH2COH and C2H5OH. Now, my method of ascending an acid, that is CH3COH converted to CH3CH2COH. Now, the best method is reduce the acid using lithium aluminum hydride, so that COOH is converted to CHOH, and we have to introduce one carbon. For that, OH is replaced by Cl using PCl5, and then ACN, so that CN is CN replaces Cl, and then on acid hydrolysis Cn is converted to COOH. And for descending an acid, a similar method is used. You start from CH3CH2 COOH, you reduce it using lithium aluminum hydride, COOH is reduced to CH2OH, then PCl5, Cl is obtained, and then alcoholic AOH, removal of HCl, the Cl from here, and this is alpha carbon and this is beta carbon, so a beta hydrogen and alpha chlorine are removed, and we get this compound, that is prop-1-ene. And prop-1-ene on ozonolysis, the double bond breaks here, and one oxygen here and one oxygen here, so that we get CH3CHO, and this one alkaline came in for oxidation followed by acidification, we get CH3 COOH. So that is the method of descending. So that is enough. Thank you.